Hey everyone, and we're back. And I'm really excited now to introduce the next speaker, Josh Goldberg. Let me see if I can get Josh up on the stage here. I got Josh next to me. Josh is a OS maintainer and freelancer from New York. And we're going to go deep into GraphQL typings generation. So I think it's going to be pretty cool to see how we can use some TypeScript with GraphQL. So Josh, take it away.
Thank you very much, Cody, for the intro. And hello, everyone. I'm Josh. Let me share my screen. I'm going to be talking to you today about TypeScript and GraphQL and how we can auto-generate our GraphQL types from TypeScript. I'm going to demystify all that generation. So the agenda is going to be a few things in order. We're going to first talk about GraphQL introspection, how GraphQL servers, their endpoints, allow you to introspect or look at the types of schemas. I'm going to talk about how you can generate TypeScript types from those introspection endpoints. Then I'm going to talk about some fun little data discrepancies from trying to match the GraphQL language and type ecosystem with the TypeScript language and ecosystem. And lastly, I'm going to talk about one of my favorite tools, Apollo, how it works with GraphQL Cogen and makes everything beautiful and wonderful. A little bit about me first. Hello, I'm an open source developer, which means I don't have a full-time job. I bum off of my spouse's health insurance, but I get to spend many of my hours each day working on open source. I tend to focus on static analysis tooling around JavaScript and TypeScript, things like TypeScript ESLint, which lets you run ESLint on TypeScript. I'm also writing a learning TypeScript book for O'Reilly that's going to be out later this year. Previously, I was at Codecademy, which just got acquired, and Microsoft, which has acquired lots of companies. Now I'm an independent consultant. You can find me on Twitter, Joshua K. Goldberg, and on my personal website, joshuakgoldberg.com. Now that that's out of the way, let's talk about GraphQL introspection, how you can ask a GraphQL endpoint about itself. To start, GraphQL servers expose a schema field describing their types. This schema has, for example, the types field on it. And if you were to query the schema types, you would get int, string, ID, query, boolean, a whole bunch of things with underscore prefixes that I won't get into, and also a list of all your types. In this slide, which has a sample schema query result on it, we have a myDataType name that shows up, which means we can conclude without looking at the server source code that this server has a myDataType type declared on it. Schema. And this underscore schema field server endpoint is going to be the root for everything I talk about today. It's going to be the root for how we introspect the names of the types available on the server and how we then query those types for things to generate, such as TypeScript types. I also want to call out the underscore type query you can run on GraphQL servers, which gives you specific information about a particular type. Here I've queried on the left for the type of name item, and I've, for each field in that type, retrieved its name. And on the right, we have some sample results from a server where we have age, ID, name, and value under the item type. So schema lets you query for everything in the server, all the type names and details on those types. Type lets you query on a specific type. Now, there are other introspection endpoints and options you have with GraphQL, but in my limited experience working with auto generation for TypeScript types, schema and type are by far the most useful and fun to understand. So in short, schema and type allow tools to automate tasks such as code and documentation generation for GraphQL servers. And this is one of the really beautiful things about GraphQL, that we have automation around all sorts of things around it. Back in the day with REST API endpoints, you had to use tools like Swagger to auto-generate, and Swagger made you set up a schema, a system for describing your endpoints. But the way you generated the documentation was up to you. Some people use a Swagger docgen, others use their own custom ad hoc solutions. But in GraphQL, we have tools like GraphQL, the standard interface. GraphQL is a web app surfaced by GraphQL servers to explore schemas and execute queries. I love this tool. It is one of the greatest things ever. I hope, because I'm speaking at a GraphQL conference, that many, most, perhaps even all of you have used it. But if not, I'm going to show it in a few slides, and really, it's a wonderful thing. It's quite easy to set up. For example, in the Express GraphQL library in NPM, there is a lovely Boolean setting you can pass to the GraphQL HTTP method. Graphical true causes the GraphQL Server endpoint to exist. That's hard to say. So I've set up a sample repo, one of two that I'll show for this presentation, github.com/Joshua K. Goldberg/GraphQL typings generation. That repo uses Yarn, but you can npm install if you'd like. So I'm just going to quickly switch screen over to GraphQL typings generation, and I'm going to Yarn start on the server. Oh boy. Already in use. Oh, pardon me. I've got a server running from my other repo that's going to be used later. Clear Yarn start. There we go. Cursor the demo as always. And on this lovely screen here, we have the graphical endpoint. And if I hit play on this query, we see that I've queried for all characters under the cartoon Hilda, and I've retrieved their age and name. Side note, great and wonderful cartoon Hilda. Highly recommend. Wonderful. Even had a movie. It's a whole thing. So this is the wonder of graphical. And you can look on the documentation explorer on the right to see the query, which has all the fields on it. And if I want to expand into, let's say, the character type, I can see that it has fields and so on and so forth. Now, to loop this back into automatic generation and such, we can look at a different query here. We can look at the schema query. And for each, let's see, types in schema, we can look at the name. Boom. Here we go. So using this wonderful little schema query, we see that I have this whole list of types. I realized only after writing the code for this talk that character is ambiguous because other languages use it as a built-in data type. For this presentation, character refers to a cartoon character. Apologies. We have character, the built-ins, int, string, ID, query, Boolean, and then a whole bunch of underscore stuff, the internals. And just to show off one more type query, if I do underscore type with the name, let's say character, and I look at the fields and get the name of each field, hit that prettify button and play, we see that this is the same list of fields that we get as in the documentation explorer, because the docs explorer uses this type of query. Awesome. Now there's a lot of stuff that you can look into here. For example, if you look up field in your query, you can see what the field type contains. It contains name, description, any arguments, type, whether it's deprecated, and if there's a reason. So if I look at, for each field, let's say the type of it, and we go into the type here, we can say, look at the name of the type. We hit play, we see that age is an int, cartoons is null, ID null. Interesting. So there's a reason why these are showing up null. It's because GraphQL has the concept of types or nested types, where cartoons is not just a simple type like int or string. It's actually an array. So if I go into my slides again, and we look at a few particular types, we see that the basic type in GraphQL is called scalar. It's an optional, meaning it could be the thing or it could be null. So it roughly translates to the TypeScript concept of optional type. But then we have non-nullable types and lists, which I want to get into a little bit more. So a non-nullable is a type that is a non-null in the kind, and it's of type something else. Let's say a non-nullable string in this case. And we saw cartoons earlier is actually type list, which is the Pythonic term for a JavaScript array. So the cartoons in the query was kind list, name null, of type string. So if we go back to our query explorer, armed with this knowledge that a field also has a kind, or pardon me, the type also has a kind, and then we also query of type, and get the of type name. There we go. We see that age is a scalar of int. Oops. And cartoons is kind list of type string. Cool stuff. So at this point, we've done pretty much what the Documentation Explorer on the right does. We looked up a particular type, let's say name character, and we looked at the fields for it. We saw that each field has a name, age, cartoons, ID, name. We looked at the kinds, such as scalar or list or non-null. And then we saw what the of type is for those complex nested types, string or ID. So using this information, you have all the stuff you need to generate types from TypeScript automatically for your GraphQL schemas. And I'm actually just going to quickly show you some code that I'm going to rush through. In the GraphQL typings generation repo, I have a README with a list of commands that I'll post later. And I have this yarn generate command, which generates files in generated types DTS. And I'll just quickly go through the source code here. First, what I did was I fetched localhost 4000/GraphQL with the query that I skimmed over in the slides and showed you in real time. Schema types, for each type we have the name and the fields. For each field we have the name and the type. For each type we have kind, name, and so on. So I'm querying the same schema information I was in real time. A few headers. We get the body JSON, and then we look at the body data schema types. So for each type, we ignore the built-in ones and the ones that are, what is this? Oh yeah, we ignore the built-in ones and the ones where we don't really need to do anything for them. Like we don't care about the float type being redeclared in our types here. Then we map the types. If we see that there is an equivalent, we, for example, I misspoke earlier. We ignore the Boolean type because it's just Boolean. We see that if there's an equivalent, such as the float type having the equivalency of number, same with ints, we export that type directly, such as export type int equals number. Otherwise, we export an interface based off of the type's name, and we generate a field for each of those interface fields, which would be these fellas over here. So the way to stringify a field is to take the field's name and then the field's value. Based off of the field's kind is how we print the value. If it's a scalar, meaning an optional thing, roughly that translates to agent or similar. If it's a list, we add the array brackets. And if it's non-null, we add the same as the scalar, but not with the question mark. So I'll note that these are slightly inaccurate. Technically, this should be string. In reality, this should be number or null. But this is generally the flow that a lot of tools, more basic ones, use to generate types for your schemas. They query your GraphQL server for the schema types. Then for each schema type, they massage it a little bit to match well, and then they print out each field in a string in your export DTS file. Cool stuff. And then again, I'll post this repo later so that you can all play with it and have fun generating your own types. All right. So there are a few discrepancies that I touched on at the end there. GraphQL and TypeScript don't have quite the same type system, so you do have to massage data a little bit. For starters, nullability is tricky. In GraphQL, fields that you query for and don't exist can be null. In JavaScript land, and therefore also TypeScript land, the default is undefined. Null is a technically separate term. So you may find that in your auto-generated types, you have a lot of or nulls, such as life. Also, the concept of an optional property is different in TypeScript, but I represented it with a question mark here for succinctness. Also, loss of numeric precision, as you saw earlier. Float and int both translate to number. There's no way in TypeScript's type system to generate the idea of a number being an integer versus a float. That would just be very complex, so they don't do it. Oh, well. And then lastly, the most important key thing here with the discrepancies is that schema types are not the same as query types. GraphQL queries don't return the same type as the schema, which is another huge change between APIs that use REST over to GraphQL servers and endpoints. In REST APIs, the API returns an object, and that's the object you get, full stop. Now you might be able to set the server up with options that might change the type, but generally there is one type for each REST API response. In GraphQL, each query defines the type it wants. Here we have two queries to some imaginary friends endpoints that gets each friend's age and name, or each friend's cartoons and ID. And each of these queries is different. One returns two fields, the other returns two different fields. So although it's very nice and fine and good to generate types for our schemas for GraphQL, we also need to be able to generate types for our queries. And that's why I'm going to now introduce one of my favorite tools ever, Apollo, which helps, along with a bajillion other things, with generating types specific to GraphQL queries. Now, Apollo provides a suite of tools for managing GraphQL, such as schema-driven code gen. It's got a whole lot of stuff. I'm going to talk about specifically some things within Apollo Client. There's also Apollo Server, dashboards, federation management. Ignore those for now, although they're great. Apollo Client is a state library that integrates closely with GraphQL requests. It's great. It's a runtime thing you can use. Apollo Client allows you to create a client object that manages your GraphQL requests for you. On the right, the first variable declaration line, const client, is us creating a new client with an in-memory cache against the localhost 4000 endpoint I showed earlier. It'll do nice things around caching and deduping requests. And one very key thing here is that it requires queries be passed through this GQL string function, which editor extensions know to give syntax highlighting, one of the cute little modern standards. All my syntax examples are copy and pasted from VS Code, and this is the native syntax highlighting with the GraphQL extension. So the Apollo client is an in-memory cache-capable object, along with other cache types, that can manage your GraphQL requests for you. And I'm going to go to specifically one thing that uses Apollo client logic, use query. There are also, again, more advanced things Apollo does, like lazy queries and mutations and subscriptions, but I'm not going to get into them. The reason why I'm really excited about Apollo and its client is because it integrates really nicely with a tool called GraphQL Cogen, which can be used to generate Apollo components, hooks, client uses, etc. from .graphql files, which allows you to have full end-to-end. I have a .graphql file that defines my schema and my queries. I'm going to then move this into my code and generate all sorts of stuff for me. And these generated hooks can be set up with TypeScript. For example, on this slide, I have a few plugins that set up TypeScript operations, and then React Apollo integrations. So I'm going to show off another repo, one that's adapted from some previous talks I gave, called a lovely GraphQL Server. Joshua K. Goldberg / a lovely GraphQL Server. And I'm going to quit my old GraphQL Server, close this out, save, go over to this one. Boop, boop, boop. Oh boy, my computer just froze for a minute there. Clear yarn starts. But here, this repo has slightly different GraphQL Server available. It has, what types do I have available? I believe it's jokes. Yeah, so this server is for jokes. If we have all jokes, you can also grab a random joke, which defaults to, I believe, 1. I'm going to use my random documentation explorer to prove, yep, it's type string. Cool. So this one is set up with the yarn GQL command. That lets you generate file mentioned in the README, source generated GraphQL TS. It has all sorts of fancy schmancy TypeScript types on it. We have scalars generated for us. We have mutations, etc. And then we have this wonderful type at the end, query all args, which is the input type for our all args query. And if we look at queries GraphQL, you see there's this query get all, which returns all, and then query random, which returns random. And if I wanted to here, I could add all sorts of fancy operations in GraphQL Cogen with generating types for these specific queries. Notice here there's no random specific one here because random is just a string. So If we wanted to do the get all query, I guess the limit would be the number for us. So if we do all and then limit, let's say 3, voila. All has limit 3. Cool. So why am I showing you this? Why am I showing you this GraphQL TS file generated from my GraphQL schema? It's because I wanted to show off the awesomeness that is setting up your Apollo Cogen to be able to create operations for you. And if we go back to here, the Apollo client is this powerful object that lets you set up your GraphQL endpoints to be used by a client with really intelligent client caching and deduplication. And then being able to code gen things based off of your documents allows you to describe in TypeScript land all the different operations you want to do in that client, which means you no longer have to handwrite interface this query results extends some other thing or handwritten type aliases in TypeScript land. You get a full description of your GraphQL server's usage in your client, which I think is fantastic. I'm going to end this talk with a few resources. For starters, these are the companion repositories, and you're going to watch me, in real time message these into StreamYard chat because I think it's fun to do things in real time in the talk. Related technical resources, GraphQL has some really great documentation on introspection. GraphQL.org/learn in general is a fantastic set of docs. Apollo's website is apollographql.com, and it integrates really nicely with Cogen, GraphQLCodeGenerator.com. That's all from me. Again, you can find me on Twitter at Joshua K. Goldberg and on my website, joshuakgoldberg.com, where I'll be posting links to the slides shortly. Thanks, everyone. Bye.
That was awesome, Josh. Thank you so much for coming up here and talking about that. So a couple questions, and I'll just throw it out there. If anyone in the audience has some questions, throw them into the Q&A section on your chat, and we'll get them answered right now. We have about 5 more minutes. We can do a little bit of Q&A. So what I'm kind of curious about, Josh, since you're like TypeScript GraphQL expert, is what do you see as like the future developments in the GraphQL space that are coming up soon? Like, what can we look forward to?
Ooh, I'm much more in constant the TypeScript world than GraphQL. I think in general, web apps are moving towards a more managed space where companies like Vercel, following Netlify and the Gatsby folks, have made it really, really easy to set up a server that has a really fast edge cached, etc. endpoint or web app on it. So I'm looking forward to doing less work to manage things like mono repos that use Apollo and Next.js, or things like Remix Run that move a lot of power for sending requests into the framework itself. So I think similar to how React kind of revolutionized how we think of state primitives for logic, I think a lot of these server endpoints are getting more and more abstracted now that we understand the primitives in GraphQL better.
Totally. Okay, so if we talk a little bit more about TypeScript, so what are some of like the best practices that teams could use if they want to work in like a fully type safe TypeScript repo project code space? What are some of the best practices around that?
It's a great question. I'd say for starters, make sure everyone's educated on TypeScript. No one is born knowing TypeScript, and most boot camps, college campuses, a lot of online curriculums don't really teach it. So I definitely recommend you have extensive docs and make sure that you have trainings, brown bags, regular discussions to help educate folks who aren't as familiar. Highly recommend using tools like TypeScript ESLint, which allows you to lint TypeScript to be able to set up good standards. And then always use, if possible, the strict compiler flags in TypeScript. Strict null checks is incredibly useful. No implicit any is great too. In general, the core TypeScript usage of your team should be as strict as possible within reason. And then I also highly recommend making sure your types reflect reality. Use things like Apollo Cogen to make sure that you have types based off your GraphQL endpoint, not handwritten that may or may not match latest updates to the endpoint. For sure.
Awesome. That's some great advice. And just to kind of link this in with some of the talks we already had, I see you're using the Apollo server, and we got to see some of the alternatives in the previous talk. what is there something specific that you like about Apollo Server, or what makes you into Apollo more than some of the other servers that are available?
I will admit I have not done an exhaustive competitive analysis on Apollo
Neither
Server.
have I.
Great. But their docs are fantastic. They integrate really well with a lot of other tools like Cogen. And I've previously used them with Next.js apps, and I've had an excellent time with them. If there is a better solution out there, that would be wonderful, but it does everything I need. So until the 10x rule is violated, I'm going to keep using Apollo.
It's a good reason. I like it. Awesome, Josh. I don't have any other questions here lined up. Do you have any closing remarks before we wrap it up?
No, just thanks for having me. Excited about Apollo and GraphQL and all this stuff. And as usual, TypeScript.
Thanks for being here, Josh. Appreciate it. We'll see you soon. So we have just 2 minutes here before Arisa. I'm probably pronouncing her name wrong. I apologize in advance. She's going to come here in just 2 minutes, and we're going to get our last talk of the day. We'll have a little wrap-up session afterwards to give some key information before we're done. I'm just going to drop off for here a minute and a half, and then we'll be back with Arisa. Thanks.